So today we're going to finish up with this Gaddis chapter 18, dealing with linked list. And first thing I'm going to talk about is this 18.3, a linked list template. Well, the other day we learned something that we could have um, a way to declare a variable by a certain name and then use it throughout. In case it ever came up that we wanted to change the program from dealing with ints to doubles, we could do it with a quick change. Now, they include this first template here, and we're going to talk more about templates later, but I didn't want to just discard it. Okay. And it's a brief mention. We're going to get into it in more detail. We're going to get in. So remember, I said how we're jumping around the book a little bit. This is something that we would have seen already. I wanted to do it so we can finish with this chapter 18, but we're going to get more detail about it later. But this class is a template, and everything's going to be referred to by this letter capital T. And what's happening here is, as a template, is whatever I declare the T to be, whatever I declare the T to be, the the whole program will work with it, be it ints or doubles. So it's a little bit like we talked about the other day, but you start getting down into here where you start seeing this T. That's the big. What's the little? What if I wrote a method to add two numbers? Okay? If I had a method to add two numbers, and if I wrote one that was integers, then I might have to write one that brings in the parameters of integer double, the parameters of double integer, of double double, of long long. Well, what this template's going to allow me to do is when I create, and we'll get into more detail with this, if I create a T as a parameter and a T as a parameter, they will both be the same, be it integers, be it doubles, be it any data type I want. So this template T, it's here. Don't worry about it. I wanted to show you that there's this generic template for linked list. Right now we have list.h, list.cpp to work with regular list, array list. Now we have, our files for our header file and our implementation file for linked list. This would be a generic one. So just mention it. I don't want to get too much into it, but this is here. Very mediocre description by me, but more details coming later. So if you look at it and say, well, why didn't you cover it? We're gonna get into that whole thing. Variation of a linked list. We're going to get more into this. It's mentioned briefly here in the Gaddis book. It's mentioned in way more detail later down the course. We're going to spend a whole day with doubly linked lists, not a quick mention of it. So Gaddis doesn't think it's as important as NIOF. When we get to the NIOF book, you'll see more. But this is a representation, and we briefly looked at it the other day, how I'm going to have a pointer to go to the previous node, and I'm going to have a pointer to go to the next node. Once again, looking at this visually, rather than just talking about it, which we did briefly the other day. What's going to get interesting with a doubly linked list? Well, my functions include delete. What if I wanted to delete a node? I got lots of pointers to be rearranging. What if I want to insert the node, a new node? I'd have to figure out how to point it to here, point it to there, and it's a cool or neat enough concept that they briefly mention it, but we're going to get into it a lot more later. Here's another example of a linked list. Instead of pointing to null at the end, it points to the first node. The last will point to the, and you're going, why, when would we have? Well, that's the advantage of the NIOF book. He gets into a lot of these topics a lot deeper than what we see here. Okay, so that's finishing out chapter 18. And what we're going to do today is we're going to take our linked list that we have. We have linked list.h and linked list.cpp, and we have that 18.4 demo program. And we did some inserting and we did some deleting, and all of that's there. And it's now yours. Okay, it's now yours. But there may come a time when we want to add more functions that we think are relevant for a certain topic. So as we learn about a topic, we may say, well, I can solve that with linked lists, but I also need a function to do a certain type of code. So if I look at number 2 to start, I want to create a function that will print everything in the linked list. Now I'm training you. Test the class by having an empty list, adding some elements first, then printing the bigger list. All right. And you may be able to take that program 18.4 and delete like we were doing the other day and add some things. You could do the insert or the append, whatever. But let's go back and look at some pictures. So if I'm currently looking at a list, I have head and there's the empty one. You can't see it. I have head and there's the empty one. So really what I'm doing is creating some test data. I have head. It's going to point to the node 2, 4, 6, and 8. That's what it looks like. That's what it looks like. Could be written a little nicer. Yeah, I know. All right. So if I said to you, yeah, we need to come in here and what do we got? Start to look at that. Shooby dooby doo. Shooby doo. Do I need to create a new node? No. I'm going to assume I already have everything that's inside of here, and I need to figure out a way to print everything. Anybody want to start to spit some stuff out?
You would use
Yeah,
a while loop.
A loop? What kind of loop?
You could use a while loop.
A while loop. Way back when in intro course, everything was about the for loops. Oh, the for loops, the for loops, the for loops. But we never really had to just learn. That wasn't the one we needed. All we ever really needed was the while loop. So yeah, I'm gonna have a while loop, and I moved it way down there. What would I start with? Somebody else have an idea of what I should actually start with?
if head
Like,
not null.
yeah, if head, if it's not empty, if it's not empty. So if head is not equal to null or null pointer or whatever you want to do, um, that's that. What if it is equal to null? Maybe I should back up there and say if head equals null, see out, list is empty. Well, I seem to always be knocking that simple stuff off first. Knock the simple stuff off first. All right, so yeah, I need to move this down a little more. Else, I know we're going to need a while loop. A while loop. I'm looking up here. What else might we need to create? So I have head pointing to my list. I have everything in there. Head's important, but
We
for
need a
this,
pointer to traverse the list.
yeah, I'm going to need some kind of pointer. And what would be a good name? I mean, the book keeps coming up with different names. I always seem to go to this one, temp pointer, because it's just temporary right now. And I need to not reach so far. I need to move my butt over so my handwriting's a little nicer. Because I am just scribbling. All right, so I do the if. If it's empty, I say, hey, the list is empty. Otherwise, I'm going to get in here. And what's the first thing I want to do?
Print out what the current data is.
I want to print out 2. Is that the first thing?
You want to check if you're at the head, and if so, print the head out without anything between it.
Okay. It's another thought.
Don't we want to set the temp pointer to head so we're starting at the beginning of the list?
Yeah, I think that might be important. Let's get temp pointer to be head. So now temp pointer points here.
Shouldn't that be up before the if loop? That way, if it equals null, that first if happens.
Possibly. Remember, I want temp pointer to be temporarily pointing to here. While it's here, what am I going to do? Print the 2, move on. If it equals null, I'm done. If not, print the 4, move on. So my looping concept is print, move on and check. Print, move on and check. Print, move on. And the check should be. So
Well,
now
since
I
you've
might,
already established that the list isn't empty by getting past the first if, you could do a do while loop since you've already basically done the first check. So you could do print
Mhm.
or see out temp pointer while temp pointer isn't null, and then increment temp pointer to next.
there's
But
thought of a do while. Do. So remember we said we are going to print it out. See out. What are we going to see out?
the value
value.
stored in temp pointer,
Tell me what to write.
temp pointer, arrow, value.
I like it.
And then increase or temp pointer equals temp pointer arrow next.
A moment ago, we said that we wanted to print it and move on, print it and move on. Now, I want you to start to become the teacher. And when you say things, be real careful and think about it. Everything Andrea said was fine. Andrea said temp pointer equals temp pointers pointer, or I think we call it
Next.
next. Yeah.
Yeah.
Now, what did I not like about her statement? Instead of saying temp pointer, this is not equals, is it? This is the assignment operator. So if you're someday a teacher and you need to be really working on students with equals, oh, this is actually equals. This is the assignment operator. So be the teacher. Temp pointer is assigned the value of temp pointers next. Just a little thing. Just a little thing. Andrew's like, yeah, it is a little thing, but be the teacher. So I just, okay, and I'm going to keep moving on. And this is a do while.
And
While
then just
temporary.
temp pointer.
For that, would it be different doing temp pointer arrow next?
In here.
Yeah, in the while loop.
Well, the
I mean,
problem is then it doesn't move on. So right now it's here, and you're saying about temp pointers next, but then it'll stall here. You never get it to move, which is what's happening here.
Okay.
You
Yeah.
could also just in the parentheses for the while, just have temp pointer itself because that will return a false if it is null,
Yeah.
right?
I'm being a little more explicit with it, but what she's saying is remember we were looking at that not temp pointer and we were looking at temp pointer. And this one, if it equals 0 or equals null or is false, that's the representation we would get with that. I still like, while we're learning about this, to make sure we don't get these bass backwards. But you like this and this, go ahead. That's fine. But while temp pointer doesn't equal null, I go up, I print out the next one, and I move it over. If I'm at the end, if it's pointing to that last null, otherwise I go back up. Questions? Questions?
Yeah, with that, with the do while loop, since it's a post test loop, wouldn't it trigger for even if head is null?
But remember, we took care of that with our if else statement. If head is null, I print out list is empty and I'm done. The questions? Yeah, and I think Andrew even said, since we checked this, we know there's at least one in there. And the do loop runs at least one time. Does that help? Okay. Jared, you're the one I want to see shake your head yes, because I know you and several others had concerns on Wednesday. We talked a little bit at the end of class, and I'm looking back and maybe another way to explain it. But I think now I'm trying to scroll up with my mouse to get to the top of this page. That's pretty sad. Next thing you know, I'm going to try to zoom in on it. So I needed my drawing to help me come up with, and this is close to real code. I think it's greater thans. It's not less thans. I'm not 100% positive. I scribbled some things, but I think I'm done thinking. I'm now ready to type. Okay. What we're going to do now is I'm going to put you in some groups. I'm going to send you out and I want you to put this in and make sure that it works. So you may have to edit that demo however it's written for your current needs for this, and that's fine. And then when you're done, I need you to do this number 4. Brought it up the other day, put it in the back of your head so you can start thinking about it. Oh, that we were talking about that in class, and I think I may have done it this way or that way. And that's what we have for today. And that's what we have. I don't know why I repeated that. Remember, your what we call it, what number list? Your number list, that's this one. Your number list, this is gold for you now. It's written. You're happy. It does a bunch of stuff we need to do for arrays. We're now adding a couple of more in just for kicks and giggles.